So it's getting recorded, right?
Yeah.
Or am I audible?
Yeah, you are audible.
Yeah. So first question was like 404 error it was giving.
Oh, yeah.
Yeah.
So there is if you look for the problem number, which is 558, you can find it.
Okay. Fine. So like, shall I start from
I
here and
tried
then?
that also, but
No,
it
you
did
can go
not.
there, right? Yeah, 558 logical or you can quickly go to lead code and then okay, you search that way.
Oh, I think I have to give a space, right? Oh,
Okay, go to the problems here in the problems here only. Don't go, don't, yeah. And in the search bar, you just type 558. Yeah, this one.
okay. So it is like, have you gone through like, I mean,
Well,
it's
yeah, it is the same Quadtree problem,
okay.
and what they say is okay. If you look at it, what do they say? It is given two Quadtrees, Quadtree 1 and Quadtree 2. You need to find an intersection of both of them. Okay, and then they have shown how the Quadtrees are represented and all that stuff.
Okay.
Okay, so what is a quadtree? It's a tree data structure which has four childs. One is the top left, top right, bottom left, bottom right, and it has a value and it has another attribute called is leaf. You know, so the
Yeah.
value is true if all the nodes represent a grade of 1, or it is false if the node represents a grid of zeros. And
Yeah.
then if leaf is true, if the node is leaf node on the tree, or false if the node has four children. Right, because if the leaf has no children, then it means it is leaf, right?
Yeah.
Okay, and if the leaf has any children, then it means it's not a leaf. So that is what it's trying to say. And then you just have to find the intersection between two of them.
Mhm.
Yeah, so
They're
it's
represented by matrix, right?
they are represented by metric. They are showing it here, but for us it's just a data structure. Instead
Oh,
of having a binary tree, we are having a similar
linear.
binary tree, but with
Yeah.
four childs, yeah, four child nodes instead of two.
Two.
Yeah.
Yeah. So what would be the brute force over here? Like,
Well, I don't know whether there is a brute force or so, but I think there is only one way to do it, and that is a recursive way. Um, so the way we do it for any other binary tree, you know,
yeah.
just it is a sort of a would say post order traversal and some part to take care in the pre order also. So that is what it is. Like if you okay, so you don't have any solution for that problem, right? You're
Yeah.
just
Yeah.
looking
Yeah.
for it right away. Right now, yeah.
Yeah.
So
Want to
that is
share?
what the whole thing is. Yeah, I can share. So anyone
Can you
has
explain
gone through
this
that?
matrix?
Sorry, go ahead, Harshit.
Uh, can you explain what the matrix represents?
Okay.
Uh,
So the matrix represent the four whatever those things are, they actually talk about these four childs. 4 child nodes. Like we have these 4 child nodes here, right? These 4 child
Okay.
nodes. So that is what the matrix is. So if this is a matrix, okay, top left, top right, bottom right. So if
Yeah.
it is a child, that it means all of them are just null. But if it is not child, then they will have values in it. Correct. Because
Yeah.
it will be a recursive way, right? It can keep growing in any direction. In the lower direction, like if it is a parent on the top, then it can go to the leaf, and then not to the leaf, but they can go to the child, and then find if there is if it's not a leaf, then again it can go down, right? So
So
similar to this one, yeah.
it's a complete tree always, means it's not like that out of four, two or three are present.
It's hard to say if it is complete or not, because if you see in this case, okay, if you take this example, right? So this is the root, okay? So then you have a top left, which is leaf. Top right is not a leaf, right? But top right is not a leaf, and then you come down and you see, okay, then this top right, top left, and other things are leaves, okay? So then if you see whether it can be called a complete or not, because the others are not leaves, right? The top left is this top left is a leaf, so it doesn't have any representation below. So if you look for the quad tree here, it is not complete or almost complete, something like that. So it is a normal binary tree, but it only has 4 nodes, 4 child nodes. That is what I would say. If you look at the intersection, also what they talk about, uh, and this is also a solution which I actually looked for in the discussions. So it is a simple way of doing it. Uh, do it in a post order. So, but for that you have a base case, right? So in the base case, you just compare if any of the quad tree, if it is null, you just return null. That is obvious. But if any of the quad tree is a leaf, okay, because you want to do a logical ORing, right? So if it is a leaf, okay,
Yeah.
and the value is true, it means it is 1, then you return this quad tree, because you don't have to consider the other also, right?
Yeah. Yeah.
Because this is a leaf, then there is no reason to go down. And
Down.
for
Yeah.
the quad tree 2, you do the similar thing. And if both of them are leaves, then you can return either of it. And if either one is a leaf, you know, then you return the other one in this case.
Quad tree.
Because, yeah,
It looks like we have seen similar problem earlier, right?
I think this is a repeat problem.
Yeah.
Yeah,
Yeah. Yeah. It looks like that.
yeah,
Because
Yeah.
same.
yeah. So if you see here in the intersect, what they say is, just come here and then keep on doing for all the nodes, right?
Yeah.
And then if they are leaves, okay, then only you actually have to be, you need to assign their values, okay. And when you are assigning the values, if all of them are true or if all of them are false, okay, then you just anyway the leaf value will always be true because it is going to be leaf, and you can assign any value of that, whatever is, just assign that value and the rest will be null pointer. Okay, so as simple as this one,
So
but
you
it's
are
only quad
checking.
implementation.
65 is checking that you have reached to the bottom of the tree. I mean, all the nodes are leaf nodes.
Yeah, so if it is a leaf, then only you have to actually assign the leaf value,
Value. Yeah.
right? Yeah, and then the value you can assign any value. That is what they say.
Yeah.
Okay, out of these any of these nodes, what you get, you just assign any value, that should be fine. And but it's being a leaf, so its no child node values will all be null. Or else, if it is not a leaf, then you just return this value,
Yeah.
whatever you
Okay.
are getting.
So time complexity, every node you are visiting, so it should be order of n only, right?
Yes.
And post order.
You have to visit each and every node. It is a tree order traversal, right? Yes.
Yeah.
Normal tree order traversal. It's only we have 4 nodes.
We can use any order, post order.
Yeah, you can. Yeah, you can, because this is like post order, correct? Because I'm actually doing all the stuff here. But this being the base case, I'm just considering the base cases also. I'm trying to take care of it. Though I don't think so. This will be a pre-order stuff, but it's just a base case condition, which I'm trying to, you know, find if there are any base cases. Then the return the values.
Yeah. Makes sense.
Okay. Yeah.
So anyone has other implementation like apart from this?
What is the application of this data structure?
Well, I think, you know, if you are present in one of the in-person meetups, Bhavesh actually presented this Quadtree, and it is used for, I'm not sure what actually that application is, but whenever you, look for,
So
so go ahead, yeah.
yeah, so the uses for that, so like you know that the service what is that service which actually help you to find some point of interest around you or your friends. So to keep that information, so like if you are at a particular location and you want to find the places, or you are using the Uber service and you
Yeah.
want to find the driver around you. So
Yeah.
on the server side, you keep that data structure to keep that information.
Yeah, it is like, you know, the
For
eateries
recommendation
around.
also?
Yeah, so the Quadtree is the root is actually like the whole world, Earth, right? And then you split into 4 parts, and that's up to your business logic. If in one leaf node, how many point of interest you want to keep, 1, 2, 10, 100, or whatever. And as soon as your point of interest increase in that particular node, you split that node into 4.
Yeah, I think he talked about Yelp, right, at that time.
Yes.
Yeah.
Yes, true. Yeah, Yelp, Uber,
Yeah.
or a similar type of service.
So Yelp actually, if you go down and look for a point of interest, and you keep on, you know, enlarging it to a point of your interest, you go to that. So that is a Quadtree. You keep on expanding in 4 different nodes, you know, and at the end you come to the leaf node, and that is your point of interest. So you are actually, you know, dividing your GPS search in 4 quadrants.
Yeah.
Yeah. But
Okay.
there are many applications of that, right?
Yeah. So in this case, like the interest place would be the leaf of the Quadtree.
Right. So because it will have a value, but you can still have, you can go one level above that also. But if you want to find more number of your point of interest, but if you want to focus on only single point of interest, then it might be a single value, right? So that is what I think. Maybe everyone has a different implementation, but the way he described the implementation was more, it was not, this was just, you know, like a binary values, right? It would have more values, maybe something like a GPS coordinates and all that stuff. Also a list of all the restaurants and everything. So that will be more intense. But just to give an example what it would be, so that is what I'm referring to.
Okay, thank you.
Yeah, then we can switch to next. So like DNA sequence, repeated DNA sequence. So DNA is composed of series of like these nucleotides represented as alphabets, and while studying the DNA, it is sometimes to find repeated sequence, and you are supposed to write a function of all 10-letter sequences, which would be a substring that occur more than once. So you can see this is occurring here, and again it is repeated. And you see CCA, and again it's repeating here. So these are the two substrings that are repeating. So,
Hey, Shashank.
yeah.
Yeah, your voice was breaking. I'm not sure
Oh,
what
sorry,
happened
sorry,
or
sorry.
other. No, it's okay. Yeah. Oh, you should be fine. You can unmute, Shashank. Okay, I think the problem statement is clear, right?
Yeah, sure.
Yeah.
So
And
like these sequences are repeating A to this, and again same sequence, and again C to A, and again the C to A is repeating. So these are the two. Yeah.
Yeah. So the first approach,
Brute force would be like, I think, take first 10 characters and put it in a set, and next time again start from A, pick next character. If you find that uh, you look in the set, if that is not repeated, then you put it in your out. If it is repeated, then put it in output list. Or if it's the first time you are seeing the pattern, try to put it into set.
right?
Or
Yeah.
so this is
or
like a string searching problem.
yeah,
So you're just searching a pattern, and if you see the pattern repetitive, you just uh, pick that pattern, and that will be your resultant candidate, right?
sliding window kind of, right? One pointer at 0, other at 10, 9, and just slide.
Mm,
Slide.
sliding window is true, but if both pointers should be at the beginning or no?
No, I thought I kept, because they have already told 10-letter long sequence.
Okay.
So
So
first one will be at 0 and last one will be at 9, and just move it by one character. Other will be at 1, next will be at 10, and so on.
okay, your window size is 10. Yeah. Okay,
Yeah,
makes sense.
I think this size.
So are you saying that?
Has anyone worked on gene databases? I mean, the question actually seems like that itself. Just wanted to know if someone has any experience with those kind of databases.
Hmm.
No, I at least I don't.
Which
Anyone in the
database are
group?
there?
What?
What database you're talking?
Gene databases.
Yeah, gene database only it is. DNA
Gene.
So
sequence.
it's
Okay.
actually gene.
No.
And people actually, try to do this kind of question itself. So they see whether they try to find a sequence, and they actually try to find if there are if that sequence has appeared somewhere in the whole long sequence of gene or other person's gene, something like that. So basically this question is that function of the gene database itself. May not be 10-letter long, but
In gene, I think it might be sequences also will be quite long, and it's not
yeah,
necessary that. Yeah.
yeah.
So are you saying, Uday, it is something different data structure altogether?
Yeah, they are not actually so there is a different set of we have NoSQL databases, right? So
Right.
there's a complete different set of databases associated with genes.
No, they can use NumPy libraries, like libraries associated with Python to do these sequences.
Not sure. Actually, this is a database. Sorry, I'm not sure of the NumPy one.
So does that
You need to
database store
multiple-
unique
Yeah.
length
So
sequences?
you need to store the DNA sequence of multiple people, and you need to check whether you got any. So even the criminal records and these all actually try to match whether it's a gene match the criminals. I mean, so basically they store the whenever there's a crime record against you or something like that. In US they store the DNA of you, and whenever there's a similar crime happening, if there's any hair or something like that, they try to extract it, and they check whether it's a DNA match or something like that.
Okay.
Oh,
Sounds good.
That's cool.
interesting.
Yeah.
So it is something like a NoSQL database.
No. I mean, there's a different category of databases called gene databases.
Okay, it's completely different. Okay, like
Yeah.
a graph database. Okay.
Do they use something like sets? In case they are looking for uniqueness. I'm just thinking out.
Okay. Interesting to know.
Yeah. Like, I mean, real world application. Like,
Right.
Thanks for sharing this.
Yeah, right. Thank you. So so as actually you said, it is like a sliding window, having a window size of 10 in this case, then keep on looking for the similar same substring like match, and then you just pick it up and put it in an output array. That's all right.
yeah.
Okay. So what approaches we can have? Like a brute force would be compare each and every 10 letters, right? And then find if it is a match or not. So start
Yeah.
from 0th and keep on. So like it will be a 2 for loops, right? One, the upper one will start from 0 to whatever the size of this S string is minus 10, right? And the inner one will be a J, which will actually have every time a 10, right? For starting from 0 and then keep on moving to the end. And then I can start from, I will move to 1 and then keep on doing it like that. Like it may be n square solution, correct?
Yeah.
And for that, you will have to have something like a set or so to actually find if there are duplicates. And then we can put that as an output arrow.
Output and then
So that will be a brute force, right?
exactly.
Okay. So it will be an n square solution.
Or you can keep in a dictionary, right? You
Yeah,
go.
dictionary will be open. I
Yeah.
will set. Yeah. Go ahead.
No, I was just saying like you take 10 characters from the beginning. You just keep in the dictionary. So you increment if you see next time. So that way you will have value more than one, and then finally, yeah, it will be often. But anyway, we are discussing the possible ways, right? So
Right.
yeah,
So the
So that's
space
that
will
is
also
one
be
way.
off when, yeah.
Yeah.
I think what Santosh explained, that necessarily won't be an O of n square. That would depend on the length.
So here the length of that string is 10, right? It's fixed. So it will be like 10 into n, right?
I think it would be n minus L into L.
Yeah. So where L is 10 here, right?
length of the sequence.
Yeah.
Yeah, I agree on that.
O of n square, why I was saying, because you start from the first index, right, of S, and then you travel for every time, take 10, 10, 10, go to the end, right? And then move your upper loops, the index to 1, and then again do 10, 10, 10, right? So if the S string is very huge, then the 10 value doesn't matter, right? So then
Right.
you
If
put
the
n
string
square.
is comparable to n, then it would be n square only.
Right.
Yeah.
Okay.
I was talking about the dictionary, like the approach in which we are using dictionary, hash map. I think in that case it will be like 10 into n minus 10.
Yeah.
Yeah.
Okay. So what will be a normal approach?
So I have coded that way only. N
Understand.
minus n to 10. Okay, so we can start with that.
No problem.
So yeah. Is my screen visible?
Right. Yeah, it's visible.
Yeah. So I initially check if the length is less than 10, then I simply return an empty vector. Now I have kept two unordered maps. This would be the one which would take care that had I seen this before or not, and the second would be an output one. Now I'm doing exactly the same thing. I'm running a loop from the first index and I'm picking a substring from that index and the next 9 indices. I'm checking if that string is there in my map or not. If it's not, I'm putting it in the map. Otherwise, I'm putting it in my output map. Otherwise, I'm putting it in the scene one. So after this, I'll have all the unique strings in my output map. Now, since we have to return it in a vector, so I'm iterating over the map and pushing all those unique strings in the vector res. I've declared the vector on line number 5.
So you don't need scene. You don't need scene right here because you're not using anywhere afterwards.
I don't need scene.
He's using line number 19, right? So that is required.
On line number 19. But
Can
you can just use the output itself, right? If you don't find the string in the output, then you can insert. Otherwise, you don't have to insert.
Right, true.
Yeah, he can do that optimization. But what happens, in this case, if we have two strings of the same value?
Yeah.
So in that case, you'll be incrementing the unordered map value, right?
Right.
Okay.
For example, if this is the string, then I was initially not using this output map. So I was getting two of these because there are 12 characters and I can have two of them, two of the same output. So I have to keep this an output map where I would check if that particular string has been visited before or not. I mean, included in the output or not.
Yeah.
Yeah.
That's right. Yeah, you can do more optimizations on that.
Yeah. Basically, I'm computing that hash again and again.
Yeah.
So that is costing me.
Right.
That can be optimized.
Yeah, but this is an optimized solution anyway, right?
Yeah.
Uh,
It would work.
It will work, yeah.
I have a doubt here, I think. Like, I have an approach in mind which is like much similar. So it's like basically we iterate, we find out all the 10 letter strings starting from index 0 and then moving on till index n minus 10.
Okay.
And then simply storing that string in an unordered map. The unordered map will be a string and the integer. And whenever for every string, we'll just keep a counter. When there are two duplicate strings, we increase the value of the counter.
Yeah,
okay,
so we can do that because that is what I said, right? The approaches, we can have different things and we can optimize on different data structures there, but almost they are the similar approach, right?
So Ronnie, if you if you're storing all those strings, then it is possible that you might find a duplicate string, right?
Right.
So you are using a hash map to store that.
Right.
Okay, then it's the same thing.
Yeah. I was
It's a
just like,
similar.
I was not sure about it, so I was just asking. I was not telling. I was just asking that does it? Can you see any fault in this approach?
No, I've done the same way in Python.
Okay, great.
Yeah, the way you said you can have an unordered map with instead of having a bool, you can have an integer value, right? That is what you were saying, Ronnie.
Right.
Yeah. That can also work, absolutely, right. Yeah. So Pradeep, you want to share yours also?
Okay, I can share.
Okay.
Yeah, sure.
Yeah. Thank you, Arshit. Yeah.
Yeah, can you see?
Yeah.
Okay, I did first two ways. First, I just started increasing solution 1, brute force way, like take one character and then take 10 characters from first index, and then check whether it is in the string, and then add it to the list, a sequence list append. But it was because this is a long length. If you have a lengthy sequence, then it will go. You will get the time limit exceed. So then this was just for a, I just wanted to see what happens. The next one I tried is the same thing as he showed. I have a dictionary. Then I check whether the code is in the dictionary. If not, I'll add 1. Otherwise, if it is in the dictionary, I'll increment. And I break if the length of the code is less than 10. I can do it here itself. Instead of doing it at the bottom, I can do it here. So I can optimize this one anyway. Then I take just the items which have the value more than 1 and create a list and then return the list.
It's a normal key value pair. If you see the value greater than 1, you return.
Yeah.
Yeah.
Okay, yeah.
So if it is a very, very
I
big
can
string,
suggest here.
go
Sorry.
ahead.
Sorry. So line number 24, you're checking if the value is greater than 1, right? I think that part you can include in the else condition so that it will be more optimized. Like there
Wait
itself,
here.
if the length is in the else part.
Which else part?
So
Line number 19?
again, this in the line number 19, you'll just check if the sequence bit of code, if it is equal to 2, then you'll directly append it to the result.
Okay, yeah, you can do that. Yes, that's true.
Yeah.
Thank you.
Because we are only supposed to check if it
I
is more
mean,
than 1.
you would not loop once again.
Yeah, that's true. That's correct. Yeah.
But what will be the data structure when we are adding?
Hash map.
Sorry?
No, after
Hash map, yeah.
No, I mean after increasing the count, which data structure are we adding it to?
No, this is a hash map. The sequence dictionary. This is a dictionary. Sequence
No,
dict.
map I understood. But
Okay.
there is an optimization set, right?
Oh, this is the list. This is a list.
Yeah, this is a list.
List.
Okay.
I'm just creating a list.
No, but
List
if
of
you are
output to everything.
no, there is an optimization set, right? If it is greater than 1,
Okay.
add it to list or something. That
Sorry, I did
might
not.
not be. No, I was just saying there is some optimization set, right? Just thinking it might not work. If it is, I mean, you might have to use a set again or something, right?
Yeah,
No.
to remove the duplicates.
No,
Dictionary already handles that.
yeah, duplicate is handled here, right? You increment.
Yeah.
No. In the else part, you you have found
Okay.
that it's already existing.
Yeah.
But if you are adding it to a list, then it might be a problem, right?
No, I'm just incrementing the count here.
Counter,
I'm not adding the.
sequence.
Oh, okay. So if I optimize it, like adding to the list.
Yeah.
Oh, okay. Yeah, okay.
I was thinking it might not be possible.
Oh, yeah. Then you can, no, you add only if it is the count is greater than 2. You just add to the list. Otherwise, you ignore. In the sense, if your count is 2, then add. Otherwise, ignore. You can
Even
do
if it is true also.
Yeah, you just if it is 2, you can just
Yeah.
add. More than 2,
We
ignore.
have to keep a.
No. I was just saying.
Yeah.
So
Yeah.
You have found for the third time. You will go into the else part as well, and you again add it, right?
Yeah.
So
If
we have to keep
if we would
if
have done it
condition
here,
that if
He's
it
saying
is
that,
equal
look
to
only the
4.
value of 2. If it is only equal to 2, then only add.
Yeah.
And if
No.
it is
Yeah.
not
I
equal to
was
2.
That's what
saying that the resultant data structure for this automation, you have to add a set. List won't be sufficient. I'm
Oh,
saying.
yeah. Okay. Set. Yes. Yeah. I understand. Yeah.
So it is nullifying the optimization again.
Yes. Yeah. Okay. That's true. Yeah. You can use set. Yeah.
So
Okay.
set will remove the
So,
duplicates, right? That is what you want to use set, correct, Uday?
Yeah. If you're adding to list, it will become a problem. That's why.
But again, 2 data structure you are adding, no, so that
But-
is an add-on, right?
But you will have to use
Without
it.
set also we can implement
Yeah, you can implement
because
anyway. You can optimize this. That's fine. Yeah, you can do that.
yeah.
Yeah.
I'm sorry, Uday, I couldn't follow your question. Can you please
No,
repeat?
he was saying that like someone, Nandini or someone suggested, right? If it is equal to, like, if you're, she said you can, instead
Mm,
of creating a list, you can do it in
Okay.
else part, right? So
Okay,
if
okay,
I,
got it.
yeah.
yeah,
Yeah,
okay,
yeah, got that, got that.
yeah, okay,
Yeah, we can do minor optimizations, but overall the approaches, both of the approach are similar,
Yeah.
right?
similar,
Same.
yes.
Yeah,
Yes.
no problem.
Yeah,
Okay,
okay.
but we can have more optimized approach, right?
Yeah.
Have
So,
we discussed about the two-pointer approach? Can
but
can it be done by two-pointer?
Yeah, but still you have to use a data structure for that.
Yeah, but there's only a set of four, right? Yeah, A, B, A, G, something. They have only four character for that.
Like, yeah, so initially I'll keep my first pointer at 0, other at 9, right? And just I'll keep on dragging till I hit the end of the list, end of the string, and I'll see which one. And I'll every pattern I'll try to keep inside the set. And if I see if it's repeated, then I'll put it in a list, output list.
Yeah.
Yeah.
okay, but they talk about something like a rolling hash also, right?
Yeah, that is
Yeah, yeah.
because data structure will, I mean, string length can be used, right?
But with two-pointer approach, we don't need to use the rolling hash, right? We just check if the character is in the set. If it's in the set, we keep advance the right pointer. If it's not in the set, then we get the length of what we have so far, and if it's greater than 10, we put it in the result.
Yeah. So what is the reason for using rolling hash? One is
Yeah.
like, I think, length,
So,
because of the large length.
so the reason is that the solution where I showed, so we are computing the hash again.
Yeah.
We are not using the hash we have previously computed for a string. It's
So you,
it's like a different string, and that is used as a key, and the hash is computed. In rolling hash, what we do is we kind of pluck out the, say, I minus 10th character, and uh, add the ith index, and we kind of generate a
Hash.
running formula for that.
It's like a 2-pointer only, right?
Yes, right.
And yeah.
so
Yeah.
he's saying,
Like a two
yeah, we'll have to use a two-pointer approach, but in this two-pointer approach, the cost of creating a hash every time is slightly more, right? So we can actually optimize that by using a rolling hash.
We can use the previous string because that hash has already been computed.
Right.
Yeah. Yeah, makes sense.
Rabin Carp.
So we
I think,
still have to use some set, something to keep track of, I mean,
yes,
evaluate. Yeah.
Right, right, right.
right.
Yeah.
That is true. I think Praveen actually explained last time, right? The rolling hash.
Exactly. I think that was Rabin Karp.
No, it was Praveen.
Yeah,
Yeah.
it's
Yeah.
same.
Rajendra might have, but I actually,
No, no, no. I told that it was like Rabin Karp
Ravindra
algorithm,
algorithm.
oh,
Yeah, it's
which
Rabin
the
Karp.
actually
rolling hash was used.
Rabin Carp actually based on rolling hash.
Yeah, yeah, yeah.
Yeah.
It's the
But it's
same.
not an easy way to implement, right? That is what, it is not intuitive anyway.
Yeah,
Did
yeah.
we have any session on this Rabin Karp algorithm?
No, in one of our daily practices, Praveen actually explained that for
Explained us.
some
Yeah.
other problem. Yeah.
All right, all right.
String pattern only, that was also some pattern we have to match.
Yeah.
Mm.
So anyone tried with that?
Yeah, I
No.
implemented using Rabin Carp.
Sorry, Uday?
No, the same rolling hash, but not the optimized one,
Uh-huh.
similar to hash code one.
Okay. You want to share then?
Okay.
foreign car.
Yeah, can this
Yeah, it's visible.
Yeah. So basically, I have allocated the values for AC, GT as 1, 2, 3, 4, and till for the length of for the first 10 characters, I am calculating the hash code. I mean, so since these are only 4 characters, I'm multiplying it by 5, and I'm adding that value to the hash code based upon the character value. If it is A, I'm adding 1. If it is C, 2, something like that. And if you have seen the Traben car, so you need to, whenever you are going to the next index, you need to decrement the value that is going out of that corresponding sequence length. So that will be based upon the multiplier itself. So I'm taking the I minus 10th character and I'm multiplying it the multiplier to reduce that uh, the the character that has gone out of that window, and I'm multiplying it by 5 and adding that character value at I, and I'm maintaining the hash code to the map of string and its count.
It's like you are changing this number to a base 5, is it?
Yeah.
So, but why are you actually using a multiplier 5 raised to 9 or not 5 raised to 10?
Because if you see that X, the top more, here, if you see the 0 to 9, the 0th character might have got multiplied it by 5 only 9 times, right? 5 power, A of 0 into 5 power 9, A of 1 into 5 power 8, till A of 10, A of 9.
Okay. So the last one you don't multiply it. Okay, right. Yeah.
Yeah.
And then you subtract that first with that multiplier because you want to remove the very first character. Okay.
Yeah, very first character, and then I'm multiplying. It's similar to the Traben carp itself. So I'm multiplying it by 5 and adding that value again. And I'm inserting it to the hash code map. So basically, the first map level is at hash code to the string, and the second map is the string and its count. Then I am just doing that, getting all the words that are greater than repeated more than once.
Okay, so that is the reason you are using map inside a map. So you don't have to use another extra data structure.
Yeah.
Okay.
How do we know that there's no collision on that hash code?
No. You will have.
If they ask.
No. You will have hash code collision. That is the reason you will have. I have a map inside. Otherwise, I would have directly kept that instead of that second map. Instead of this map of string to integer, I could have kept another directly the string itself.
Collision means that there is already a same string present, right?
Yeah, the different string map to a same hash code.
So one hash code can have multiple strings. That is why I have hash code to map of strings. It can be a list of
okay.
strings.
Yeah, that takes care of the collision there.
Yeah. You will, that is the reason in Ravencarp, if you find that hash code as equal, you compare this whole string again.
Okay. So you are actually only saving on the creating a new hash every time.
Yeah, I mean, I just decrease the comparing with just reducing the comparisons slightly. That's it.
Right. Hmm.
Can you repeat that part where you said that if two strings have the same hash, even then we compare that string, those two strings?
Yeah, that is why we have a second level map, right?
Okay.
Map inside a map. Yeah.
Yeah. So if it the same if two different string gonna have the same integer, right? So it map to the same key, but then when it go into the value, that distinguished by the second map. So the first string gonna be different than the second one.
Okay. Yeah. So our answer would be both of those strings or uh, one of them or
So if it's duplicate, it will be only one, right?
okay.
So yeah.
Yeah.
Yep, that's good. But it's not so easy to, code it.
Come up. Yeah.
That is what, even though I think Praveen also explained last time.
Yeah.
Yeah, but it's good. At least I'm at least able to relate it now and understand it. So maybe next time I can try again. Yeah.
So whenever see pattern matching problem, so we
Uh-huh.
should think of rolling hash or Rabin carp or KMT, right? I mean, at
Okay.
least, yeah.
So,
Yeah, the length of the string is not that big. Here it is 10 itself. Otherwise, you will have overflows and these all, and you need to use a prime factors and these all. That is where it becomes even more difficult actually. Here, if you've seen my code, I didn't use any mod or something. In the real implementation of RavenCarp, you might have to use mod and these all.
Yeah,
Yeah,
mod.
true.
True.
To avoid the overflow.
Yeah.
so that is very challenging, right? You will have to. Okay.
So how did you design hash function? Oh, yeah, got it. Like putting the notes.
This was Ash what you did, yeah.
Yeah.
Yeah,
Maybe
it's not really complicated to implement that Rabin carp. So if you see that on Geeks for Geeks, they have implementation. It's straightforward. If you know the concept, so you can easily digest that.
The template is fixed. Yeah.
Yeah.
Yeah. Yeah, it was clear because last time you explained it, and
Yeah.
now it's much clearer. But when you have to handle the corner cases, like the way you said, you have to remove one character and then add that,
Right.
the way he has done, those things are very tricky. And also to take care of the overflow.
True.
Yeah.
yeah, we can extract that to a function, right, and write a function very well. So every time we need a rolling hash, we just calling that.
Yeah, maybe. That can be done, yeah.
So it's a ZigZag conversion, and this is the string, and it works like three. I mean, they have given you the number of rows. So first like PAY, and then again from here diagonally you go to top. Again this, keep on repeating this pattern. So we need to write a code to represent that pattern. So how do you like?
So it's a literally zigzag conversion.
Yeah, exactly.
Okay. And
You
there
got
are
it.
no constraints, nothing. It's just a string, and then you have the number of rows.
Yeah, I don't think any constraints
Yeah,
here.
yeah, and nothing to worry about. So it can be any character, anything. They have not mentioned.
Exactly.
Yeah.
The previous question was asked in Google. That one, that pattern matching one.
Oh, really? Oh, okay.
Yeah.
Okay, so for this, the brute force would be like what? Will that be a really good brute force for this one?
I don't. I mean, whatever will be that will be the normal code. Like code you can optimize,
Uh-huh.
but no data structure will help here, right? It's a language kind of testing.
The brute force, brute, brute force, I think could be, process one character at a time, right? So, we just go on top to the bottom, right? One by one. And then from the bottom going to the top, just one character at a time.
Yeah, that is the
And
optimized also. I think here. Like,
yeah, but we just go, follow that flow, right?
yeah.
And then we know the number of row.
Whenever you reach a stop or bottom, change the direction. Like whether you have to go down or up. Like once you hit 3, number of rows 3, then you have to go up. You change direction. Again, when you hit row 0, that means you are at the top. You have to go bottom.
Yeah. No, but Leon, how are you going to construct output string?
So we know the number of row, right? And let's say we have a buffer for each row, and we just go on, as Hashan say, we just go from the top. When we reach the bottom row, then we go up, right? And then we go down again, and we're going up. Just think about we going down and going up only, right? And then this process keep repeating. So let's think if in this case we go down PAY and P, and then that's like one iteration, right? The next iteration we go to the next column A, L, I, and then S, right? And we keep doing that. So it break it down into like iteration and what we need to do at each iteration.
But when you're saying we can have 3 different rows and then add the character every time for the each and every whenever you're accessing an iteration element, you just put that in the output. Yeah, okay, the row.
Yeah.
But I thought that was an optimized version. Okay.
Is it? Because it follow the natural one, right? Because we see the first character is P going first row, the second one going to the second row. Yeah.
So that would be almost like an optimized version, yeah. Because
I think the optimized one would go like, we go from the one row we complete, and then go to the second row.
Oh, that
and
way,
go third
yeah.
row. Yeah, we just like know
the index
what index we need to use.
Yeah, that is true. But yeah, so it means there is no brute force. This is the only brute force what we have. Yeah, okay, that makes sense.
Yeah.
Because this also is fine, right? That also passes if you have the number of rows, the way Leon said. It is accepted by lead code and it works. Yeah. But the more optimized of index manipulation, it is very challenging to implement, but the time complexity can be almost similar because we are just going through each and every element.
Order of passing string one time.
Yeah, time complexity may be similar, but when we run it, it would be faster because the value on the same row, it would be more likely to cache by the register than to jump from one row to the next row.
Yeah, makes sense. Yeah, so yeah.
So would you like to share, Leon, something like code?
No, might work.
Okay. Yeah, so yeah, that was a good approach.
Yeah.
So any other approaches you want to share that? Anyone wants to
Mine
share?
is like what Leon said just.
Uh-huh.
Like first I created a buffer, like 3 rows are there, 3 such I'll create. And let's say if you have only one string, I mean one row only, if they are giving you number of rows one, then directly you return the string. And I'm going to every character and I'll keep on appending. I keep on appending and go to the next row, next row. The moment I hit that, I went to the third row, I will change its direction to go towards the upward. And so on, keep on, and at last just join the result.
Okay.
Like
So you
two times you
it.
change the direction. Once you hit the bottom or you hit the top.
Okay.
Yeah.
Yeah, it's a pretty concise and neat code. Yeah.
Yeah. Other than that, any other optimization or things?
So let's say we have printed, we have added PAY in our result vector. So now when we change
Result.
direction, how do you like move ahead in the second row, like fill P for the zigzag thing?
Yeah. So let's say you added PAY, you reached here, right?
Right.
When you reach here, you will multiply your direction by -1. Next time when you take the character, what will happen? This J will be at that time either J will be what? Your I mean you'll be at this what do you say, at the last row, right?
Right.
Now so when you reverse the direction, what will happen? You will go to the second row, because J plus direction I am doing, and direction is -1. Initially your direction was 1. Now your direction is -1. So 3 minus 1 will be 2, right? So you will reach here 2, and again 2 minus 1 is 1. You will reach here.
So you reach at J equal to 2 and okay.
Yeah. I mean index, I think I said wrong. Like it is in 0, 1, 2, not 1, 2, 3. That depends like how we indexing. 0 based indexing or 1 based.
So will P be appended ahead of A? Is that what we want?
Yeah. Yeah.
Okay. Okay, I'll have to see this.
Yeah, so this is correct. Yeah, I think so. Yeah, I never tried the optimized way, but I thought this was the only optimum way. But yeah, as Leon was saying, we can have
We can calculate
way better.
indexes,
Right.
right?
Yeah.
Yeah, that way, like I've not tried. For example, for first row, so like if row is 3, right? Then you do 3 plus 1. So that way you are at like if you check that first example, then you will be at A. So next time from A again add 4, then you will be at H and then N. And next move to the next character, right? A. So then you next your first one you take first you compute what indexes you want to do for each row. For first row you do 4, and next row you do 2, and next row you do 1. I'm not sure. I don't think that this is correct. Maybe the last one. So that way, like you compute what for each row, what indexes you want to jump, and then when you're computing by character, so you just jump based on this indices and select the characters and append it to string.
So I didn't get the one what you said. First is 4.
Yeah, first.
What is 4 stands for?
So 4 is like the number of rows is 3, right? So like for if you take the first example, can you scroll to the first example, Shashank, if you don't mind? Yeah. So here, right? This is 0, 1, 2, 3, and this is 4, right? A is 4.
Okay.
So that is 4.
No, actually 0,
sorry.
1, 2. Yeah, A is 4, correct.
A is 4.
5, 6.
Right.
This is 6. So A is 4. So if it is 3 rows, number of rows is 3. So always this one will be at 4th position. If it is number of rows is 4, so this you get 4 plus 1. This one will be at 5 for the first row. PI. So next one you jump 5, it will be at N.
Okay. So
Okay.
that is a difference between those two elements.
Yeah, that
Okay.
can be also. Yeah. But you need to compute this how much you need to jump, you need to compute in advance. That way you can, when you are passing through these strings, right, when you're like you pass this first P, and then next you can just add the indices, like take the first index, add it to this P index, and then jump into I, and then from I jump into N, and then you append it. The next one you take character A, right? So A from A, you jump into next one is L. So for L there is 1, 2, 3. So your index is 3. So first one is 5, next one is 3. So next one is 2, and next one is 1. So you need to compute this. I've not done. I was just thinking, seeing that you need to compute this index, and then based on index you can jump and create the output.
Okay. So you're saying at the first row and the last row, the gaps will almost be similar?
Similar,
Yeah,
yeah.
it's only the middle one which will be
Yeah,
different.
middle one you need to compute. Yes, yeah.
Okay.
That was, yeah.
Okay, that's good.
You have implement. Oh, you have not implemented it.
No, no, I was
Okay.
not implemented.
It was a good
Yeah,
one,
this
right?
is the more optimized one, right? This first, we
Yeah.
don't need to create an array of buffer, and second, we don't need to look through that array of buffer and then stitch in them together. This one, we only need one buffer.
Yeah.
Right.
The
Good
space
one.
is optimizing here.
Yeah. So the way we have to break it is like first we need to find the gaps for each row. That is very important.
Yes.
Yeah, and then we actually use those gaps. But when we start iterating from the string, if we start iterating from the first P, then complete for the first row, then you move the pointer to A, and then complete for the second row.
Yeah,
And
for I
then
is equal to 0, I is equal to 1, you just keep going, right? 0,
Right.
1. Yeah, so 0, 1, and then 2, and then you just 3. So based on like you just have to, your I will be going through these numbers, but your index will be jumping, picking up the strings, characters to append.
Yeah.
And just check that you're not beyond that string length, and then I think those things you need to take care.
No, that's a very good way.
Actually,
Yeah, go ahead. Sorry.
hi, this is Deepak. Actually, I have done this problem using this computation only.
Oh, okay,
so
good. Yeah.
It's just one miss. It's just a single calculations, and on the basis of row, we can just calculate the middle elements. So for the 0th row, we just and I can explain just a minute. Let me share.
Sure.
Are you able to see my screen?
Yeah.
Yes.
Yeah. So suppose row number is 1, so it is just, we don't need to do anything, we just return the string. But after that, I just started with the 0th row, and if the row is total number of row is 3, that means other than the 1, 2, 3 character, there will be one additional character in the middle row. And if total number of row is 4, if we skip starting and last row, there will be extra character in the middle row. Okay.
Right.
So if we do that calculation, this formula will come, start plus total number of row, and I need to ignore the first and last row to calculate the extra elements. So that's why I just done the -2 there.
Okay.
And for the and just iterate on the row, and then iterate on the basis of start position. So it will work.
Okay, so your next will actually be the one which keeps on moving. Okay,
Yeah.
because your start is moving.
Yeah.
Yeah, so yeah, this is a more optimized way because Pradeep was discussing like creating those as a separate initially in an array. Yeah, but this is also a very different way of doing it. Yeah.
But in both the cases we have the same complexity, right? Yes. Here
Yeah.
also it will be O of n, and what Pradeep explained, it also has a O of n.
Yeah, that is true. This is more optimized, but at least Pradeep mentioned, the way he explained, it is a very quickly you can pick it up. Yeah. So, but this is more implementation details. Yeah, it's very complex. Yeah, but that's good. Yeah, they are both are good.
Okay. Thanks.
Yeah.
Yeah. Any questions on this one?
No, I think it's perfect.
Okay. Thank you. Thank you, Deepak.
Pardon?
No, I said thank you, Deepak. Yeah. He
Okay.
shared that, right? Yeah. So I didn't code for the complex solution, but then when Pradeep was actually explaining, I thought, yeah, it might be a different way of doing it.
Yeah.
And it might be possible to break down that way and then arrive at the way Deepak showed. Yeah, yeah, you can come to that. Yeah, like initially I thought it would be very difficult to do.
Yeah, but it's a
But
good one.
yeah, Praveen, go ahead.
No, I said it's a good one. I mean, the
Right.
one which Pradeep was getting.
Okay. Okay. So I
Okay, thanks.
think we are done for today, right?